Hello, I'm Derek Hitchens and I'd like to present a concept study for the Severn Estuary Eco Barrier. First, what's special about the Severn Estuary? Well, it has a number of designations. It's a special protection area, it's a Ramsar site, it's a special area of conservation, it has a number of sites of special scientific interest, and it has a number of well-known archaeological sites. It has a variety of habitats: salt marsh, intertidal mudflats, rocky intertidal habitats, subtidal sandbanks, and so on. There are a number of adjacent cities, as you can see there, and it has some well-known resorts in the area: Minehead, Watchet, Bridgewater, Burnham-on-Sea, Weston-super-Mare, Clevedon, Portishead, Penarth and Barry, to name but a few. On the 30th of January 1607, there were major Bristol Channel floods, which drowned some 2,000 people. Houses and villages were swept away, 200 square miles of farmland were inundated, livestock destroyed, wrecking local economy along the coast of the Bristol Channel and the Severn Estuary. Devastation was particularly severe on the Welsh side, and Cardiff was the most badly affected town, with foundations of St Mary's Church being destroyed. The coast of Devon and the Somerset levels as far inland as Glastonbury Tor, 23 kilometres from the coast, were affected. Eyewitness accounts told of a huge and mighty hills of water advancing at a speed faster than a greyhound can run. And it is supposed that a storm surge of some 9 metres on top of a spring tide of 14 metres occurred, which could overwhelm today's existing sea defences. The Somerset levels are at risk from both tidal and land-based floodwaters. There's the 1607 Bristol Channel floods mentioned again, but in 1703 waves came 4 feet over sea walls. The sea walls were breached again in 1799, filling the Axe Valley with seawater. In 1872, floods covered 7,000 acres. In 1919, 70,000 acres were inundated with seawater, poisoning the land for up to 7 years. So storm tides are an existential, burgeoning threat to the levels and the Severn Estuary. There have been other storm tides. In 1953, there was a storm tide in the North Sea. Major floods struck Netherlands, Belgium, England and Scotland. A combination of high spring tide and severe European windstorm over the North Sea caused a storm tide. Wind, high tide and low pressure resulted in water levels 5.6 metres above mean sea level. Overwhelmed sea defences causing extensive flooding. In England, 307 people were killed in Lincolnshire, Norfolk, Suffolk and Essex. And as a direct result of this disaster, the Thames Barrier Programme was started to secure central London against future storm tide. But the Severn Estuary has no barrier against storm tides. Looking here at the Severn Estuary, we can see that there is a notional boundary describing the limits of the Severn Estuary, presented by this dotted line. And we can see a number of resorts in there: Minehead, Watchet, Burnham-on-Sea, there's Bridgewater, Clevedon, Portishead, Penarth, Barry, Hinckley Power Station, and there are a number of low-lying areas and hills. There's the Quantock Hills, Mendop Hills with the low-lying Somerset levels between them, Cotswolds, the Wye Valley. This area here is the Gwent Levels historic landscape, and we have the Heritage Coast there. Altogether, the Severn Estuary is a unique and precious natural environment with a population of 1.04 million and rising. And it does have, as we say, an existential threat from destructive and overwhelming storm tides and storm surges. What is a storm tide? A storm tide, and a storm surge, is a tsunami-like coastal flood associated with low-pressure weather systems. And the Severn Estuary is especially prone. Tidal resonance gives spring tides of about 14 metres range. If you add to that low-pressure wind-driven surge of perhaps 5 or 6 metres, that would give you a storm tide of more than 20 metres. This would overwhelm sea defences, inundate the land, destroy property and drown people. On top of that, we have to cater for the effects of global warming. Rising sea levels, increasingly severe storms and deeper depressions could lead to future storm tides of 25, 35 metres, more, who knows. However, it's not of immediate concern since it's a rare coincidence. And that rare coincidence means that you would have to have a high spring tide plus a deep depression over the Bristol Channel raising a dome of water, plus stormform winds up the Bristol Channel, creating what some people might call the perfect storm. Then there's tidal resonance. The incident wave, caused by the moon's rotation around the Earth, is reinforced by reflections between the coast and the continental shelf edge, giving a much higher tidal range at the coast than at the centre of the ocean. The effect is most striking when the continental shelf is about λ/4, or a quarter of a wavelength, wide. And the Bristol Channel has the second, some would say the third, highest tidal range in the world. And with the Severn Estuary funnel, it forms this 40-metre tidal range, which is unique. The mean sea level is set to rise by more than a metre by the end of the century, increasing the tidal range in the estuary from 40 metres to who knows. And the estuary tidal range has been of chronic interest to those with a view to creating tidal barrages. And tidal barrages have an unfortunate potential to seriously damage estuarine ecosystems. Many governments have proved reluctant in recent times to grant approval for tidal barrages. The LOUVRED plant off the Brittany coast of northern France was the first and largest tidal barrage plant in the world. It's the only site for full-scale evaluation of the ecological impact of a tidal power system operating for 20 years. The isolation of the estuary both during construction and operation of the tidal barrage was detrimental to the flora and fauna, however. After 10 years of operation, there's been a variable degree of biological adjustment to the new environmental conditions, which is politico speak for, well, the ecology was seriously damaged and has recovered somewhat, but the flora and fauna are different from those that were there originally. Sandbanks have disappeared, beaches have been badly damaged, and high-speed currents have developed near sluices. Tidal barrage is not the only way to extract energy from the tide. However, it has to be said that tidal barrage maximises the electrical energy generation using the potential energy of a dammed lagoon or estuary. This dams the river or the estuary twice per day, and it generates on the ebb tide only by preventing outflow until the downstream level drops before opening sluice gates to rush water past or through turbines. In the process, it seriously disturbs the estuarine or riverine ecosystems, both during construction and daily during operation. On the other hand, there is tidal stream, which generates more modest electrical energy from the kinetic energy of river flow using, for example, underwater propeller turbines, which are like wind turbines, but submerged and much smaller. It has to be said, technology of these underwater turbines has yet to mature, but some systems are proving successful in commercial use. Tidal stream does not dam the river. It generates on both the flood and the ebb tide, and so 4 times per day, and there are no sluice gates. And with care, it causes minimal effect on the estuarine or riverine ecology. Tidal stream technology has yet to mature, and it comes in several styles and configurations, as you can see. That's a Gorloff turbine. That's Gorloff turbines horizontal. And there's another thing, a poor thing but mine own, for shallow waters. The question arises, is it practicable to build a Severn Estuary eco-barrier corresponding with the Thames barrier, so not to be confused with the barrage, that 1. Protects low-lying coast, including population, towns, cities, power stations, resorts, the Somerset levels, etc., against flooding and storm tides, which would overwhelm even current upgraded sea defences. 2. Future-proofs the estuary's habitats, archaeological sites, SSIs, areas of outstanding natural beauty, hydrology and salinity in face of rising tides and global warming. Conserves the unique, precious, dynamic estuarine ecosystems. 4. Potentially assists with draining the Somerset levels. 5. Generates sufficient energy, consistent with 1 to 4 above, to fund its own construction. And 6. Provides a post-construction legacy of green, lunar, renewable energy for the region. Before looking at that, let's look for inspiration to the ancient clapper bridge at Tar Steps in North Devon. You can see here a number of stone plinths in the river with flat stones over the top, making a path for pedestrians. If you look closely, you can see the water streamlining as it flows between the plinths. And there is the eco-barrier concept. As you can see, it also consists of a number of plinths, although these are significantly larger. And there are platforms over the top, creating a deck from one cliff at one side to a cliff at the other side. There are gates at the middle. There could be more than one, but there's a gate there to allow shipping to pass. But between the other plinths, a pair of plinths forming a bay, between the other plinths there are clearly some form of shutter. But the shutters, like the gates, are open, and the water is passing freely from one side to the other, either on flood or ebb tide. And if there are any hidden turbines, there is no sign that they are generating power on the surface. Construction, concept of operations. There's a broad philosophy to introduce successive parts of the structure in sequence, very few at a time, without any dams or other impediments to flow. So piers, plinths, etc. to be constructed from the water surface downwards. There would be therefore a carefully phased introduction, allowing the estuary to rest and recover between activities. The whole to progress in phases with recovery breaks punctuating the phases. And what would the notional first stage construction look like? Something like that, although I don't think it would be quite that simple. There's the first plinth. It's a vitally important element. It has to be strong enough to resist a tsunami-type surge. It's streamlined above and below the water to minimise drag, and it has a hydrofoil planform to improve turbine efficiency. It's constructed from the surface downwards to minimise impact on the estuary bottom, and it may require arch extensions. And there will be a post-construction pause to assess the ecological impact of creating it. There's a head-on view of a pair of plinths, and there they are with a platform over the top creating a bay, and you can see in the bay towards the rear there is a downward shaft leading to a submerged turbine, not visible. That turbine could be suspended from the top of the platform, but it could also be fixed into a pile driven into the bedrock. There's a head-on view. And now we can see a perspective view which is showing the deck is underlit. This is underlit using light pipes feeding daylight from the upper surface underneath, so that there is no shadow being cast on the water surface. This is to avoid attracting marine life. Supports for louvered shutter. And there's the first louver fitted with thrust bearings at support and at the base, which is down towards the bedrock. There's all the shutters fitted and open. There's the shutters closed with a median tide. And there'll be quite a bit of shutter research to be carried out. The open louvers would serve as streamlined inlet guide vanes. And there are alternatives to a louver shutter, as I've shown there. The louvers have to be light yet strong and have no impact on water quality, flora or fauna. And they'll be designed such that the incoming tidal forces tended to assist the louver motors to shut and seal the louvers. There's a double bay, underlit, and a second double bay, also underlit, both sets with the shutters open, which is the normal position. There's a head-on view. There's a block of 5 bays, shutters open, all underlit. And there's multiple bays disappearing into the estuary mist, no longer underlit because it's dusk and there's no sunlight on the top deck. Tidal stream energy. So how much electricity could be generated sensibly and soundly from within the Severn Estuary eco barrier as a whole? It would be a mistake, a serious mistake, to extract too much right across the river. That would affect water salinity, drift, deposition and erosion, and increase the danger to fish and sea mammals. That would be repeating the mistake of the tidal barrages. And it should be remembered that power generation will build up only slowly using tidal stream energy as each new bay is commissioned. Orchestrating the eco barrier. We would consider it appropriate to control each and every bay individually and collectively. We call that orchestrating the eco barrier, bay by bay, and as a complete suite of bays. And we have a number of tools that we could use. Shutters could be open or closed, turbines could be generating, they could be idling, or the turbines could be driven as fans by passing electricity through the turbines. And the turbines could of course be raised or lowered within their water column. We would use embedded estuarine sensors to monitor and regulate the overall eco-barrier behaviour so as to maintain the estuarine ecosystem, hydrodynamics, and to optimally extract tidal stream power and to anticipate storm tides, of course. Such orchestration would appear to be essential for the eco-barrier complete and necessary during implementation when the eco-barrier might be incomplete with bays, blocks of bays and gaps. Tidal stream power developments. Seaflow is a marine current turbines enterprise installed off the coast of Lynmouth, which is quite near where we would propose putting the eco barrier. Lynmouth is in North Devon, and this is something of an experimental exercise, which was successful. And the MCT is to proceed with a DTI part-funded double turbine consisting of 2 600 kilowatt rotors attached to just one steel pile system called CGen. That would give, at full blast, 1.2 megawatts on the one steel pile. It is, however, large. CGen weighs in at some 300 tonnes, with twin 20-metre marine propellers. And it indicates the potential for barrier tidal stream power generation per bay. With tidal energy converter technology still in development, however, it's difficult to predict the power per bay in, say, 20 years from now. I have made a guesstimate, a swag, a scientific wild-ass guess, that the power per bay could be between 0.5 megawatts and 1.5 megawatts. It's quite a wide range, but that keeps it reasonable. So based on the nearby Lynmouth experience, it's, quote, not unreasonable to suppose, unquote, that subject to developing technology tests and trials, that between 0.5 and 1.5 megawatts might be safely extracted from the tidal stream through one bay using 2 or more turbines. Each bay would be different, however. They have different heights of water column, different tidal stream velocities, and there may be mutual interaction between bays, which suggests that the turbines and the configuration would also differ bay to bay, so there may be no such thing as a standard bay. And the full output would build only slowly over however many years it took to complete the full Severn Estuary eco-barrier span. Tidal stream power. And in, say, 20 kilometre span, there could be as many as 400 bays at 50 metres span for each bay. Why the narrow span? The robust construction is necessary to withstand the tidal surge. And all the bays together could generate 400 times the power per bay, which means 0.4 plus or minus 0.2 gigawatts for 18 to 20 hours per day, which would be exceedingly green lunar energy. And that should be compared with Hinkley C nuclear power station, which is rated to come on at 3.2 gigawatts. The Severn Estuary Eco-Barrier economics. Building the Severn Estuary Eco-Barrier would be bootstrap economics. So the first bay would sell electricity to the national grid, so defraying the cost of a second bay. The 2 bays would do the same, so funding a third bay, and so on. So the eco-barrier would progressively fund itself with an exponentially rising income given the initial investment in the first bays, hence bootstrap. You can see it here on the diagram. We have funds here which are filled up to begin with by so-called pump priming. Provides income, goes into funds, and we use the funds to build the first bay. That building process removes some of our funds. We pause, we commission the bay, which takes more of our funds, and then we operate and maintain the bay, which takes more of our funds, and we generate electrical power, which we sell to the national grid, which starts to restore our income and increase our funds. And then we go round and build the next bay, and so on, round and round. We also use the funds to install ecosystem sensors, which we use to develop a sensory database. And we develop the eco-barrier orchestrator system. And as bays come online, we commission the bays, we integrate the bays, and we commission the Severn Estuary eco-barrier and manage and orchestrate the eco-barrier. And that is the end of the construction phase and moving into the final operating phase. Notional project profiles, time and tide. Here you can see top left of these 4 diagrams. At the top left you can see a dynamic model, system dynamics model, of the causal loop model I showed you in the previous slide. And you can see here pump priming, income, funds, building the bay, and then accumulating the bays. And you can see expenditure at various stages, sales to the grid, and so forth. So this is a dynamic model showing the construction over a period of time. And you can see that the rate of bay building starts off quite slow. I'd like to say that's because of planning, but in fact it's because with very few bays available, we're having trouble with funding, and the funding builds up only slowly. You can see along here, we're bobbling along the bottom until finally, at about month 80, 7 years, shall we say, into the contract, we are able to start building bays consistently. And we finally finished the 400 bay at month 240, using the figures here. And I just made the figures up to suit. So this is 20 years it took using this model. You can see the number of bays starts off fairly slow and gradually builds up exponentially to reach 400 after 240 months. Oh, those are all movable feasts, and with more pump priming you get going much more quickly, of course. And what are we getting out of it? Well, this is the cumulative tidal flow power guesstimate. And if you remember, I said each bay would produce between 1 megawatt and plus or minus 0.5 megawatts. So 0.5 line, 1 megawatt line, 1.5 megawatt line. At the end of 240 months, the 1 megawatt line would be producing 0.4 gigawatts from 400 bays, and that would be 0.4 megawatts plus 0.2 minus 0.2. So about there somewhere, but quite a wide bracket. Could be more, could be less. View showing open surge gates with dusk hazard lights. Very little underlighting because it's night time. The need for a drawbridge depends on the height, and that's going to be a subject for research. The height of the eco barrier must exceed the height of any potential storm tide, and that has to be established. It have to be at least 9 metres above the highest contemporary spring tides, for 40 metres, to accommodate any stored surge, plus allowance for impending rise in mean sea levels, magnified by tidal resonance in the Severn Estuary, and an increasing dome of water in the surge from deeper forecast depressions. Could it be another 10 metres? Possibly another 40 metres? Difficult area, but research is required here. However, it indicates that the overall structure will be large. Could be anywhere between 30 metres and 45 metres above sea level. And a drawbridge will be required unless the height is sufficient to pass shipping underneath. And by way of reference, the Severn Bridge has a 47-metre clearance beneath it. Finally, open for business, shown with surge gates open, and there could be several surge gates for ease of maritime traffic. Open for business. You can see the water streaming through the bays. There's a night view showing night hazard lights. And it now appears that there's a storm tide approaching. It's closing time. How can the eco barrier assist in draining the Somerset levels? Well, the mouth of the River Parrett, which is a principal drain of the Somerset levels, is tidal. And that can cause the drain to back up rather than flow into the estuary, so prolonging flooding on the levels. And this apparently happened during the 2013-14 floods. The eco barrier could, in such extreme circumstances, close off incoming waters such that only a low neap tide occurred, reducing or stopping altogether tidal backup in the Parrett and other rivers, but without undue effect on wildlife. This would be an unusual occurrence, but appears both feasible and reasonable. Location, location. Where to site this Severn Estuary eco-barrier against storm tide? There are, as you can imagine, many criteria. The eco-barrier should protect as many vulnerable locations, SOMERSET levels, SSIs, habitats, low-lying coastline and population as possible. And ideally it should butt onto cliffs to prevent storm tides from skirting around the ends of the eco-barrier. The tidal stream velocity at the site should be sufficient to generate electrical power efficiently, and the ground beneath the eco-barrier should be suitable for driving piles into bedrock. And following maps may guide the choice of preferred location. Here we see the tidal regime, and you can see on the left that to get up to 2.5 metres, which is preferred, there are very few places where you can put the barrier. Looking at the topography, again, here's the notional boundary. You can see cliffs here, these dragon's teeth, cliffs on the other side. You can see erosion, deposition. Deposition is going straight into the mouth there of the Parrett. Erosion coming from there. We can see this area here, which is land less than 10 metres above mean sea level. These dotted lines indicate low-lying coastlines, there, there and there, all around there, all up there, all around here. The preferred location on the face of it appears to coincide with the boundary of the Severn Estuary, since that protects most, if not all, vulnerable sites and situations. There are cliffs at both ends, and there's adequate water tidal stream velocity. However, locating the Severn Estuary eco-barrier on or near the estuary boundary to the south would impinge on the Exmoor Heritage Coast and the southwest coast path in West Somerset, and to the north it would impinge on the Glamorgan Heritage Coast. So a second question arises. Is it possible to reconcile an eco-barrier on the estuary boundary with the interest of preserving the unique natural environment of the Severn Estuary? First, the Severn Estuary eco-barrier would be very green anyway, as its name implies. It protects the estuarine environment against destructive and deadly storm tides, and it generates very green lunar tidal power, as opposed to fossil fuel, nuclear, biofuel, wind farms and so on. But the eco-barrier can also be physically greened by turning the eco-barrier deck into a natural park area accessible by the public via existing coastal pathways, etc., and forming a natural habitat and corridor for birds, insects and small mammals. By planting the upper decks with trees, bushes, grasses, etc., indigenous to the two interconnected coastlines, and by providing pathways for pedestrians and joggers, buggies for the disabled, cycle paths for cyclists, etc. And it would become a potential tourist attraction and provide income for both South Wales and West Somerset. Not a new idea. This is the so-called garden bridge over the Thames, which has been proposed for Waterloo. Here's a view of the Severn Estuary eco-barrier being ground. You can see here stout hedges. I think the blossoming trees might be a bit over the top. And here you can see the hole over the surge gate. Successfully greened, I think. So can we protect the Severn Estuary against impending, highly destructive storm tides? It seems doable. Challenging? Potentially feasible, but can we afford it? If we use an eco-sensible project model, we could have a self-funding eco-barrier that preserves, even enhances, the unique Severn Estuary environment, ecosystem, dare I call it a biome. We could have a healthy supply of truly renewable lunar energy for the nation. And we could provide an income for through-life development, operating and maintenance costs. It looks like a win-win. On a more sober note, government has a duty of care to preserve, conserve and protect the vulnerable Severn Estuary against flooding, increasingly severe storms, rising tides and temperatures from global warming, already threatening our coastlines. It's conceptually feasible and affordable to construct a Severn Estuary eco-barrier against flooding and storm tides, corresponding to the existing Thames barrier, also built to combat storm tides. It would be a major civil engineering project, phased in over many years, and it would need government backing, careful planning, research, design, development, technology project and financial management. But it would bring protection, conservation, employment, income and energy to a largely deprived area. It would be self-funding, harnessing tidal stream renewable lunar energy that with care will not damage but conserve the unique and precious estuarine ecosystem and environment and its people. Government initiative is recommended soonest, and that could take the form of a comprehensive EU-supported or funded feasibility study. Thank you for watching. Thank you for listening.